So my name is Maximilian. I'm working for EclipseSource. And at EclipseSource, we are these days, the last years, building tools and modeling tools on a daily basis. We do so by using Theia, and we also do so by using VS Code, but most of the time we use EMF Cloud for building modeling tool-like tools. So what is EMF Cloud? EMF Cloud is a project that exists at the Eclipse Foundation for a couple of years now, and the intention of EMF Cloud is to provide you with reusable components for building those kinds of tools. When I say those kind of tools, I mean a tool that has a data model that is synchronized between different editors. So the idea is that you have one semantic model, but you have different editors that show parts of that model in a different way. So usually that's a tree editor, a form editor, graphical editors, textual editors. And you want all of them to work on the same state of that model and to show that in a synchronized way. And often there's other additional functionality like validation and diffing merging. And the idea of the EMF Cloud project is to help you to reduce the initial effort, obviously, to build those kind of tools, but also, last but not least, to reduce the maintenance efforts for products based on those components. And those components are in industrial use, so they have received some hardening, so you don't have to start from scratch when you build your own tool. Where is EMF Cloud now? I've mentioned that it's a couple of years old. So what we have been able to deliver is components that do fulfill the requirements that I outlined on the previous slide. And those components, first and foremost, are the model server. The idea of the model server is to provide that aforementioned synchronization between different views. So editors can connect to that model server and can retrieve a model, can change a model, can get updates for a model so that they can update their representation. This is all built based on Java and on the classic EMF, the classic EMF modeling framework, the classic Eclipse modeling framework. And then there is editor support for the different kind of editors. So we offer integrations in EMF Cloud. There's a tree editor component. It runs EMF in the backend. We have a graphical integration with GLSP. That's a talk that Philip has given on Wednesday about a graphical language server protocol platform framework. That's about creating graphical editors in the browser with web-based technology. And we offer an integration in EMF Cloud to integrate that with EMF in the backend so that you can connect to this model server. Same goes for the tree editors. Same goes also for form-based editors. So we offer an integration with JSON forms that even allows you to migrate from EMF forms to have form-based editors connect to the model server. And last but not least, you can also connect with Xtext to the same, Xtext-based editors to the same model server so that you can support textual DSLs in a modeling tool. In addition, we have integrated EMF validation in the backend so that you can run your validation rules. And we have integrated EMF compare so that you also have support for compare and diff. All of that is also wrapped up into demo products that show you how you can use those components. They're also meant as a blueprint if you start a new project. And one of them I'm also going to show today is the coffee editor. The idea of the coffee editor is to have a simple example of representing a coffee machine, the components of a coffee machine, and the workflow to create a coffee. And in this coffee editor demo, you can see how those components are used. And there's a second example, an eCore editor, that you can also take a look at how those components are used. So that's all there. So what am I talking about today? There is something missing in EMF Cloud, which we realized over the last couple of years and which we got to work on this year with quite some focus. All of what we have for now is very good for reuse, and it's very good for a migration use case. So if you already have an EMF-based tool in RCP, you have EMF models, you have eCore models, you have business logic that's implemented against the API of the code generated from those eCore models. You have validation rules. Then that's good, because you can reuse most of that in the back end. Still, you have always the effort to redo the front end, but you can reuse a lot of stuff. But of course, that reuse doesn't come for free. It comes with some compromise. And we realized more and more that, especially for greenfield projects that don't have a migration use case, that's a burden. So there's 3 bullet points that I put here that I find most difficult with that approach. You have this mixed stack, right? You have TypeScript and JavaScript in the front end, and then in the back end you have Java, EMF, sometimes even OSGI. So that is a mixed stack, and that will worsen your developer experience. Then you have a quite inflexible deployment, because you have those Java-based implementations that need to have Java running, that need to run in a backend that's probably deployed in a container. So you can't move them to the front end, which is, for certain applications, something you want to do, to offload from the backend, which is the 3rd bullet point. The backends tend to get quite fat. I cannot publicly speak about customer project tools, but for the coffee editor, as an example, we are running that in a Kubernetes cluster, and we have configured it to have 2 gigabytes of RAM for the container running it. Now, that doesn't sound much unless you reflect that the deployment strategy of those kinds of tools for Theia as well as for VS Code is 1 container per user. So if you have 1 user connected, they need a container with 2 gigabytes. Another user comes in, another 2 gigabytes. So that's not very efficient. And if you talk to any of the infrastructure guys that run such a Kubernetes cluster, they can't believe it at first, that this is really what you're doing. But that's how it is for now. And part of that is due to the fact that we have Java processes running in the background that just take a lot of resources. And if you don't have any benefit from that, then something is missing for you in EMF Cloud. So what's in the making? What do we do about that? So what we started this year is to create a 2nd line of components in EMF Cloud. And what I mean by a 2nd line is an independent line of components. So they largely don't share code, but they are not intended to be used intermixed with the existing line of components. And this line of components is based on a uniform TypeScript-based stack. So it only uses JavaScript, TypeScript, and runs a node. It allows you flexible deployment options. We will get to that in the later slide, but you can not only deploy the front end into the front end, so the editors into the front end, but you can now also deploy the entire application in the front end if you wanted to. And that results in slim or even no backend at all. So you can really cut down on the resource consumption. The example that I'm going to show today, with even the most conservative deployment option that is running only the editors in the browser and all the other stuff in the backend, even that option comes down by half to even a full order of magnitude in terms of resource consumption. So the coffee editor that I'm going to demonstrate with the same model that we have for the Java-based implementation takes 250 megabytes instead of 2 gigabytes to run all that. So we really hope to cut down on the resources, even if you don't go for a full front-end deployment. What's the status on that? So I mentioned that we started with that this year. Having said that, it's based on components that we already had in production. So we have quite some experience with that, and these components have already hardened in production to some extent. And we are pouring significant resources into that and will be doing so. Since it's existing components, with the involvement of other parties, we are currently in a legal release process. So we need to get the IP signed off so that we can open source it. And we intend to release it in Q1 2024. So, having said all that, can we finally take a look at that? As a disclaimer, if anyone, I mean, maybe that's interesting for me, who has seen the coffee editor demo in the Java-based version before? Okay, for those people, it might be a bit disappointing, because what are we looking at? We will now do essentially exactly the same from a user perspective, only that it's now running on a pure TypeScript-based stack and a node. So I have a terminal here. I'm going to start the application. This is going to bring up Theia, so launch a node process essentially. I'm going to navigate with a browser to that. I had the crazy idea to do another pull before the demonstration because someone fixed the bug, so I hope everything goes well anyway. Thank you, Matthew. That might help. So this is the form-based editor that we have here, and I can also bring up a textual representation and a graphical representation. So now I have to fight a little bit for space. Yeah, maybe the graphical editor can give me some space. So, yeah, so that we can see everything. So this is now this coffee model. I didn't spend a lot of time in making a great model there. On the right-hand side, you can see a graphical representation of the different activities that you can do while brewing a coffee. In the middle, there's the entire model as a textual, very JSON-like DSL. And on the left-hand side, we have a form-based editor to edit the same content. And we can see that there is some overlap, right? We can see there is the preheat here, which is one of the activities. I can also find it here. Please don't be confused that the ID is also preheat. It was a great idea by one of our developers. So the name is preheat, and we can also see the name reflected here in the diagram. And if I now go ahead and change that to something else, I can see that it updates everywhere, including the textual editor and including the diagram. So that's achieved by a component in EMF Cloud, which we will look at in a second, which is called the Model Hub, that synchronizes the editor. Now, to pick something else, so I can, of course, also do the same thing here, super brew, and it updates also, and it also updated here in this editor. And finally, I can, of course, also go ahead and rename that back here in the graphical one, and it synchronizes vice versa. This is not only working for those kind of changes, obviously, but you can also do other stuff. So I can pull in a node here. Now that will be somewhere in the textual representation. So I search for pause, I find that here, and I change it to wait, just as a final demonstration. So, seems to work. That's good. How does it work? So I already mentioned that we have this Model Hub, and the Model Hub provides centralized editor access. So the idea is that all the editors connect to the Model Hub, and on the Model Hub, they can work with the model. So what do? They can load a model from a URI, from persistence. They can get the contents of that model, and they can save that back to persistence. Unsurprisingly, that's also very much what the model server did in the Java-based product line. We can read-write to the model. We can subscribe to the model, which is, of course, important. And lastly, we can do undo-redo, so we get a command stack-like functionality. These are all mandatory functions that are available for every registered model at the Model Hub. There's also some optional ones. You can resolve references if you have any. You can validate. And you can also write your own custom API, which is useful if you have more complex operations on the data model, like a composite operation. You can write custom APIs so that the editors can use that instead of implementing it by themselves every time. All of that is modularized, so that's also a learning that we had, and it's modularized by something that we call capabilities. The idea of that is for providing editing support for a certain type of model M. So in our example, for the coffee model, you need to provide capabilities. Namely, you need to provide two capabilities that are mandatory. You need to provide persistence, basically implementing load and save. And you need to provide an editing domain capability, which is about getting the model contents, undo, redo, and patch that is writing to the model. You can provide additional capabilities for cross-reference resolution, for validation, and also for your custom API, obviously. And only when you provide those capabilities, at least the mandatory ones, for a particular type of model, the Model Hub will be able to deal with that model. So you register that with the Model Hub. So in essence, the Model Hub can later on also work with different modeling languages, given that you have provided contributions that provide those capabilities for those models. How does that look like in practice? So we have some experience with that already. Of course, you could implement that with other stuff, but I just wanted to give you an overview of what combinations we've already dealt with in products. So for persistence, we have been using Langium for certain products so that it gets serialized as a textual DSL into a file. We have also built custom implementations that serialize into JSON or XML for that same purpose. For the editing domain, we have implemented a component in EMF Cloud in that second product line, which gives you a very simple JSON patch-based command stack. For cross-references, we have also used Langium, as well as for validator. And for validator, we've also have some experience with using AJV, which is a JSON schema validator. And for custom API, I mean, you need a custom implementation. That's quite clear. Now, if we look at that for the coffee editor, how are the capabilities implemented there in this demo product? We use Langium for persistence, for cross-references, and for the validator. And we use for the editing domain the JSON command stack. And we have some parts in a custom API, for example, for adding automatic tasks that is implemented in a custom implementation. What's the architecture of the coffee editor? How does that work? So we had that tree editor with the forms. We had a GLSP-based editor. And if you know something about GLSP, you know that the GLSP editors always consist of a backend and a front end. So we have that. The backend being responsible for creating a node-based representation from the semantic model. And we had this text-based editor, which is basically a Monaco editor that just ships with Theia. Now, the tree editor and the GLSP editor, they connect to the model hub, unsurprisingly. The Monaco editor doesn't. We'll come back to that in a minute. Now, the model hub will figure out that the URI that is requested there is of the type coffee model, and therefore we need some kind of contribution that helps us to provide those capabilities. So there is a coffee model contribution that provides persistence, validation, editing support, editing domain, and also cross-reference resolution. And how does it do that? Well, for the editing domain, it uses this JSON command stack that ships with EMF Cloud. And for all the other capabilities, namely the persistence, cross-referencing, and validation, it uses Langium. So it persists into a textual representation that we've also seen. And the Monaco editor, since it speaks LSP, it can just directly connect to Langium. It doesn't need to go through the model hub. So if we look at a round trip, a typical round trip, the tree editor, for example, will be the one loading the URI. We'll tell the model hub to get the URI. The model hub will figure out that it's a coffee editor model. It will go to the coffee model contribution. This will in turn go to Langium because the persistence capability is implemented that way, and will load up the model. And then at some point, the tree editor, after it got the model, it will make a change. It will send that change to the model hub through the coffee model contribution and put that on the JSON command stack that will then eventually change the model in memory. And then the other editors will get notified. There is a slight complication in here because of the Monaco editor. The coffee model contribution will also update the AST once the model has changed, so that also Langium can update here. And finally, I just want to have that for the next slide, essentially. Stuff is going into the workspace of Theia and is stored there as files. So, deployment options. That's something I promised earlier. You should have more flexible deployment options now. The classic deployment is this one. So we have all the editors in the front end and deployed, running in the browser. It's maybe the better word. And that's also the case with the implementation of the primary product line, or the first product line that we have for EMF Cloud. So there also the editors run in the front end. But that's that. Now, for GLSP, we can move the backend also into the front end. That is a feature of GLSP, but we only unlocked that feature of GLSP because the model hub is now TypeScript-based and because the integration of GLSP with the model hub is now also TypeScript-based. It used to be Java-based, and now we can use that, can move that entire process also into the front end. And then we can go even one step further and say, okay, we can also run the model hub and the responsible coffee model contribution as well as the command stack in the front end, because it's all TypeScript-based and it's all wrapped up nicely that it can do so. And we could even go one step further and also run Langium in the front end. Or for that sake, we could even say, well, do we really need a workspace in that container on a file system? Maybe we just keep everything in the browser. And actually, I mean, that's not a theoretical discussion. So that's really something that people have been asking us. If you have a smaller model, why would you even want to have a backend, right? Maybe there's a button in the end where you can push the result somewhere, but for those use cases, what they really wanted to have is something that doesn't require a backend, because they maybe have 10,000 of users and it just becomes expensive to run it there. Or, which is also quite frequent cases, they have a version of the tool that's more a lightweight version, where you don't have to pay for a subscription for running the backend. You run all of that in the front end, but if you do more complicated stuff that doesn't run the browser in a decent way, you can buy a subscription and then push some stuff back into the backend so that your front end doesn't receive such a heavy load. So those are options that you get by those more flexible deployment options. So, of course, the question would probably come up anyway, which one should you use now? And this is the typical answer that people give in those presentations, but I think it's true. It really depends. Right? Should you use the Java or the TypeScript-based ones? And I think there is three decision criteria that are quite important. So how valuable is your existing code? Do you really need to keep that? And how valuable is it for you to have ease of development, to have a more easy development for future stuff that you implement? How important for you is the migration use case? Do you have an existing tool that you need to migrate, that you even potentially need to keep around for a transition period, for a longer transition period, so that you need to have interoperability between the old tool and the new tool on a daily basis? Or how important are deployment options for you? Is it important for you that it scales well in the cloud if you deploy it to many, many users? And something that I didn't mention so far, which is true, for the Java-based implementation, there is one advantage that it has that comes from the fact that it integrates so tightly with the EMF ecosystem. You can use everything from the ecosystem of EMF minus UI. So, for example, EMF Compare, I mean, integrating EMF Compare into the Java EMF-based approach was pretty straightforward. It probably, or I know that it isn't for a pure TypeScript-based approach. And you trade that off against the slim memory footprint, of course. So all in all, it's a very tool and even customer and even a team-specific trade-off, right? Maybe your team also has different capabilities. And we've done that in customer projects for customers with varying results, right? So that is really also a process of trading off. Sometimes the new products also, people are willing to compromise on the functionality of the new products. To say, okay, we don't need that functionality, therefore the more features of the Java-based version is not worthwhile, the additional effort, and then we can go to the TypeScript-based solution. And there's other cases where people say, well, probably this tool is going to be in production for us, the existing RCP EMF-based legacy tool, for another 10 years, at least 5. We just cannot cut off now and have an entirely separated line of development. So in summary, we are on the way of enhancing EMF Cloud by a second independent line of components, which is uniformly TypeScript-based stack with quite flexible deployment options and with slim to no backend. And we have based that on components that are already in production. We intend to release that in Q1 of next year. If you're interested now, we can explore early access options. I cannot promise anything there, but if you're interested in a collaboration, please contact me. We can discuss stuff here so that maybe you can get an early preview of what's already there. Currently, the EMF Cloud website contains the old components. We will, as soon as the legal process has completed, we will push an update on the website where you can also find then information about the new line of components. And of course, you can contact me anytime via email or here at the conference, or you can drop by at the booth to ask questions about that. The QR code, by the way, is the slides, so all the pointers you can then get from the slides. I also uploaded them to the conference website. Yeah, and with that, I hope that you find some interest in this new line of components. We are really looking for feedback, and it would be great to get to know what you're up to with your tools. We have plenty of time for questions, so thank you very much. Is there questions?
Hi, Christian from Typefox. We haven't met yet, I guess. I was very curious about using Langium for your persistence capabilities, and I wonder actually when we can expect a PR for serialization.
Yeah.
So how do you solve that, or did you have kind of a generator?
So maybe Philip, you can take that question.
Yeah, so currently we have custom serialization. Basically, we have implemented an own generator. But our intent is basically, you saw that this is a very JSON-like serialization. So obviously, there is a lot of room for generalization of that. So we plan to do that, and also are very interested in getting basically random orders in the grammar. Because in the next step, what we really want to do is that you can basically specify a meta model, then generate a grammar that is very JSON-like out of it, and then use the generic serializer and deserializer out of that, and use that basically then as a modeling backend. And we are more than happy, of course, to add anything that you find useful for the generic Langium users to add to Langium, of course.
And apart from that, you could, of course, also have a custom serializer if you want to have one specific textual representation. But we want to make it easy so that people can have something out of the box. Yeah.
Maybe we should swing up on that.
Okay.
Because also, of course, to me, I think there is two use cases or two different types of users potentially. The ones that are more interested in a real modeling framework, they don't care too much about the serialization, right? For them, serialization is just a means of getting it persisted. If you have users who are also interested in the language, in the textual language as a front end, then of course it demands manual interaction. And then of course Langium is raised to the developer. Otherwise it's more like a framework thing. And that's why I think it's really important to keep those both use cases very easy to access for developers.
Which is also reminds me of a feature that I forgot to mention, but that's also just super cool with Langium, is that you get the indexes built for cross-reference resolutions. It's a feature that in EMF was never great, to say it like that. So you could do it with EMF query or manually, but having an index just built like for free by a framework, that's really cool. So the whole cross-reference resolution stuff is pretty awesome. Any more questions? Matthew.
Don't worry, I can project my voice.
But then it's in the recording.
Ah, yeah, we need to have that.
I'm very interested in the performance improvements on memory from migrating from Java to TypeScript. Mm-hmm. What is it that, or what improvements did you do or bring to cause that to happen?
So,
and a little follow-up also, whenever you have the sliding line for front and back end, is there a consideration for making just microservices and trying to figure out where you can deduplicate so you can only have one instance of that?
Okay, so two questions. Question number one, we always have an open source week once a year where we do a lot of open source in our daily work, but that's a week where we just retreat into a remote location and we work at one particular problem. And last year's open source project was about finding out what really drives the resource consumption of those modeling tools that we had so far. And we thought, well, maybe we can optimize here and there, and but in the end, what really turned out to be a major factor is Java by itself. And we had in this coffee editor tool, we have multiple different Java processes, so even combining them would bring down resource consumption. But in the end, Java eats up a lot of the resources. And just by removing that without optimizing the other components a lot, that already drives down memory consumption significantly. And to the question, and there's some other tricks that you can do, sharing more things and dispatching multiple users onto one container and all that. But like this ratio of how much effort have you got to put into something and how much benefit you can reap, if you can get rid of Java processes or combine multiple Java processes into one, that's gonna save a lot of memory. Yeah. And also startup time in the end, but that goes, yeah. The second question about moving that line, so still in that picture, we're in this old model of one user per container, but of course it will make it easier in the future to combine those services for multiple users. We tackle one problem at a time, so we haven't done something in EMF Cloud now to dispatch multiple users, for example, to the same model hub. So that's also an interesting question that I often get is model hub intended to be used for multi-user usage? No. So the idea is multi-editor usage. One user using multiple editors on the same model. That's the intended use case for now. I mean, that could change, but we want to promise something we can keep, and that is multi-editor access, so synchronizing editors of one user in one container. Any more questions? Then, with that, I would like to close. Thank you very much for coming and sharing your opinions on that and your questions.